Okay, so 57, which has the garden that looks like this, and we're looking for the width of the border. So we're told that this is what we're trying to find. So we'll call that W, and that's W all the way around. Okay. And you're told that the inside of this has a dimension of 25, right, by 40. So that's the given information. You can give the given information in a picture, and it also tells you that there's an area. What area is given? The area of the strip, right? So this area, this shaded blue area, is 504 feet squared. So that shaded blue area is 504 square feet. So how would I look at that? How would I get the area, the blue area? How would I write an expression to calculate that?
The area of the inside
Yep.
one subtracted from the area. No.
Subtracted from the area of what? The area of the inside
It would have to
one.
be the total area to get 500.
Yeah, the total area. So we have to get this big long length and this big long W, right? So this is how I would approach it. I would say that this total area, which is L times W, and then I would subtract this, the inner area, this, subtracted by the inside area, and that's going to equal the area of the strip, right? Does that make sense? All right, so the big outside area is length times W, but how do we get the big L and the big W? What would those be equal to? The big L would equal what? 40
plus 2W.
40 plus 2W, right? Because it's the inside the 40 plus the two widths on either end. So what would this one be, the W, the big W?
25 plus 2W.
Yeah, 25 plus 2W, little w. Okay, so this is big W and this is little w, and that's a 2. All right, so we're going to say that this is actually 40 plus 2 times the little width of the strip times 25 plus 2 times the little width. That's the outside area. The inside area is 25 times 40, right? So what's 25 times 40? 1,000. So this is 1,000 on the inside. So we can just subtract 1,000. And that's going to equal the area of the strip, which is what? 504, because that was given up here. So the area of the strip is 504. And now if we FOIL this out, you're going to have 1,000 plus 50W plus 80W plus 4W squared minus 1,000 equals 504. And these 2,000s cancel, so you have 4W squared plus 130W equals 504. So how do you solve a quadratic? Because that has a squared in it. What do you? Yeah, we have to get it equal to 0. So we have 4W squared plus 130W minus 504 equals 0. So you can plug that into the quadratic formula, but since you need a graph, I'm going to suggest that you just let this whole expression, let this equal y. So type in y equals this function into your graphing calculator, and what you're trying to do is you're trying to solve for when is y 0. So if you graph that in your graphing calculator, right, you're going to get some crossing points, and one of them is going to make sense for the width. Because this will be the function, this parabola will be the function, and the crossing points is when that is going to equal 0. So you can solve it either way, but you need to show a graph, and that's how you would use a graph to solve it. All right, so recording here. So you have to give the answer. You have to finish solving this and give the answer, obviously. All right, so now we'll go to the next slide. We have 59. The Sweet Drip Beverage Company sells cans of soda pop in machines. It finds that sales average 26,000 cans per month. So we're going to write down what we are given, 26,000 cans per month, when the cans sell for 50 cents each. So when we're selling them at 0.5 each, we sell 26,000. For each nickel increase in price, so if I add 0.05 to the price, the sales drop by 1,000 cans per month. Right. So since we haven't done a lot of these recently. Hopefully you've had some experience in Algebra 2 doing these. Let's just think about a model of what's happening here. I'm going to go ahead and read. Question A says, determine a function r of x that models the total revenue realized by Sweet Drip, where x is the number of 0.05 increases in the price of the can. So we're trying to find the revenue realized. So let's just think about this. It says, let x be the number of 5-cent increases in the price. So before we come up with a revenue function, let's think of what this means. If we sell 26,000 cans at 50 cents each, right, that's when x is equal to 0. Now, if I increase the sale price by 5 cents, my sale price is going to be 55 cents. And how many cans am I going to sell? 26,000 minus what? 1,000, right? So I'm going to minus 1,000, right? If I sell them for 60 cents, I'm going to do 26,000 minus 2,000, right? So the first line I put in here, that's when x equals 1. There's 1 5-cent increase. The second line I put in is when x equals 2. Now, revenue is going to be the number of cans sold times how much you sell them for. So if I let x be the number of 5-cent increases, what happens to my cans is I get 26,000, and then I have to subtract 1,000 times x. For every 5-cent increase, I subtract 1,000 cans off my sale. And the price starts at 50 cents, and it goes up by 0.05 times x. So that's the revenue function. All right, so since this is the revenue function, you're going to graph, part B says, find a graph of r of x that clearly shows the maximum. So when you graph your window, you want to make sure that you see this parabola, you see a maximum value. And when you read it, you're going to graph r versus x. And when you read off of your graph, this x, this is the number of 5-cent increases, right? So let's just say, I'm not going to give you the answer here, but let's say this is the max, and if x was 5, that would mean that you've added 5 times 5 cents to your price. So you'd add 75 cents. If x was 6, you would have added 30 cents to your price. So that's what this x value is. It's not the number of cans sold, it's the number of 5-cent increases.